It's quite a journey.
There's so many things there that can kill you. Oh,
Oh yeah.
we're live. All right, we're live.
Hello, everyone. You got to see me and Ryan talking live. Hi, everybody. How are y'all? Thank you so much for joining us today for our Starburst and Tabular workshop. We're going to be taking you from zero to Data Lake Hero. And with me, I am Monica Miller. I'm a developer advocate at Starburst. And with me, we have the CEO and co-founder of Tabular and the co-creator of Apache Iceberg. Ryan, thank you so much for being here with us.
Glad to be here. This will be fun.
Yes, we're gonna have a great time. So I think we're gonna go ahead and get started. In the meantime, let's just do a quick rundown of what we're gonna get going, so any late tricklers in can catch up. But we're going to be going over basically we're going to do a introduction into Trino. We're going to do an introduction into Apache Iceberg. We're going to talk about why Trino and Iceberg are the modern data lake combination that you want for success. And then we're going to get into it with a hands-on workshop. So we're going to take you from nothing to something, and we're going to get you getting started on your data lake and using Iceberg tables, all with Starburst Galaxy. So we're going to use the two SaaS offerings today, Starburst Galaxy and Tabular, which are going to get you started so quickly. And that's why we're able to do this lab. But in the meantime, before we get started, if you want a Trino and Iceberg cheat sheet, go ahead and scan. Look, Ryan's got them.
Yeah.
They're handy.
It's really helpful. I have mine laminated at my desk.
There you go. So if you want basically a guide to all things, print it out, laminate it, let us know, tag us on social, all the things. Go ahead and do that. And don't worry, if you can't get it right now, we'll send it out after. You'll have all the details. So let's go ahead and jump in. I am going to be talking to you about Trino first. So basically, we're going to get started there. So what is Trino? Trino, previously known as Presto, is a fast distributed SQL query engine that is designed to query those large data sets distributed over multiple data sources. So originally, Trino was created at Facebook because the data scientists were having a hard time running different queries. They couldn't run more than 10 a day on their Hadoop file system. So they were really struggling and they needed a different solution. So Martine Traverso, Dane Sundstrom, David Phillips, Eric Wong are four creators of Presto, all created, formerly named Presto, now known as Trino, created this to solve that problem. So basically, it is known for that petabyte scale. And there are a couple of different use cases where you can use Trino. The first one is for interactive data analytics. So that is when you just want something to, you send a SQL statement through a client tool, and essentially you're trying to get the results as quickly as possible. And basically this allows for large queries on data that we couldn't have before. You can do testing hypothesis, A/B testing, visualizations, dashboards, all the things. The other thing Trino is known for is that high performance analytics of object storage, what it was built for, that Facebook origin story. And essentially, it's just helping you run at that petabyte scale, at that scale and performance that previously wasn't available beforehand. The third thing for Trino is for that centralized data access. So basically what that's saying is that we think that all of the data should be in the data lake, but that's not necessarily possible all the time. And you'll have data within the orbit. You'll have data maybe in Oracle or MySQL or other places that you need to reach still. So we have that federated capability. So while you still have that centralized access, you can federate your data from multiple different locations. And then lastly, Trino is used for batch ETL processing, so across different systems. So typically data is loaded into object storage, let's say S3, and maybe, for example, you want to prepare that data to be processed for an ad hoc user or a BI tool. So often this can be a pretty resource intensive operation, and Trino can do this quite well. And basically, when you're running these workloads, it's resilient to different failures that you could have. So, for example, let's say we have some event data that's landed in S3 in a JSON format. And basically, what you want to do is you want to transform that data into something that's more relational and optimized. And basically, you can use Trino to do that until you get your final output that you want. So this is an example of where Trino sits in the stack, kind of visualizing what I just talked about. You have your BI integration tools, you have client support, and Trino is that connecting layer that lets you connect to all of your different data sources, including Iceberg and Tabular, your object data stores, your relational databases, your NoSQL databases, anything from real-time analytics, and Trino lets you connect it all. One cool thing that we see a lot is that dbt is used with Trino as the data lake query engine. So it's a way to basically do those transformations on it. And I've even seen people do a dbt Trino Iceberg combination beforehand as well, basically to do transformations on the lake. So how does Trino work? Essentially, basically, Trino is a distributed system, and it consists of a single coordinator node and multiple worker nodes. And what that gives you is it lets you add worker nodes if you want to scale up or scale out. So you can add additional horsepower, basically get those results faster if you need it. So essentially, you can think of the coordinator node as the brain. So what happens is a SQL query will be sent to the coordinator node. And basically, it will parse it, it will plan, it will optimize, it will get the query where it needs to be. It will schedule that query for all of the worker nodes. It will put out different tasks. And while it's doing that, while it's creating that plan, it will talk to all the data sources and get the metadata information and get any security checks or any other things it needs to do to basically format that plan that it's going to be creating. So once it does that plan, it sends it to the worker nodes, and the worker nodes will do whatever they're assigned, and then they will be communicating back to the coordinator node as they need. And basically, we'll get that end result so that you can then have that result for the end analyst, and it's all pretty and ready to go. So Trino is a fully pipeline execution engine. It's also called a MPP processing, massively parallel processing engine. And that's just because it does all of the work in parallel. So you're not really waiting for those sequential tasks in order to go. It lets you process fast in parallel. So Trino is the best query engine in the world. That's what we believe pretty confidently. It's used by some of the best companies in the world also, and it's definitely a great option for you going forward to use. Sometimes it requires very extensive resources to be run successfully. It's difficult potentially to manage if you don't have a big team. You have to build security around it. Access control is another factor, and then support. We like to say at Starburst that we have the Trino experts because we have all four of the creators. But basically, you may not have those people on your team to fix it and know the code as best as they can. So it does take up some money and time if you're not well equipped to manage it. And that's why we have Starburst Galaxy, which is a managed Trino platform, which we're going to be using later today. And essentially what that does, it takes all of the greatness of Trino and it adds in, some awesome, amazing things like gravity, like an analytics engine, and basically creating that single point of access for you. But we have some additional things like discovery, data discovery, schema discovery, some governance. You can search for your data within the platform. There's a lot of cool things that we have just to make it easier to manage your data. So that's essentially Starburst Galaxy, what we'll be using later today. If you don't get this QR code, don't worry. We'll send all the links out. They'll be in the chat as well. But yeah, there we are. That is a little bit about Starburst. And so now I'm going to hand it over to Ryan to talk about Iceberg.
Awesome. Thank you, Monica. So Iceberg is actually a very similar story to Trino. We basically were working at a very large, on a very large data platform, and hit some problems. I really liked the thinking about problems in terms of like, what were people actually trying to do? Because that's really one of the distinguishing features of Iceberg as a platform. We weren't just trying to solve like cost and performance, being the data team where we basically had the budget line item for all of the cloud and data processing and things like that, and cost and performance was a big deal. But we also saw that what was driving a lot of that cost, right? Why we needed the performance was data engineers just trying to get their jobs done. And they would either go and do something silly or accidental and run up a giant query bill, or they would just be stuck and need to go reprocess a whole bunch of data because they had some correctness issue and just didn't know where the data was and had to roll back and reprocess. So we actually, when we created Iceberg, what we did was we realized that there were three areas we needed to solve, and not just cost and performance. The table format, the old table format Hive, had correctness issues. So, as you see here, I don't always overwrite partitions, but when I do, I delete the data first. You were left with this choice of, do I delete the data and then replace it? Or do I duplicate the data and then try and delete the old? There was no way to do that in a single operation. So readers were never affected by what you were doing. And that bled into problems of cost and performance and all sorts of issues. We also saw both of those really have a strong effect on the productivity of our data engineers, our data analysts, our data scientists, and basically anyone working with the platform. And what we realized was that a lot of these problems, or most of the problems, had this central focal point, which is that the table format itself was just wrong. The table format didn't keep enough metadata that we could easily go find the data for a given query and just process the data that we needed. It didn't give engineers metadata operations to do common things like rename or drop columns. It let you do it, but then you just had data quality problems after that, which is another productivity drain. And then there were the correctness issues. So we realized that all three of these things were caused by a very simplistic table format. So what we did was, next slide, we basically just did, oh, I thought this was going to be my Velociraptor slide. We basically just designed a table format, and I'm going to ruin the joke from later, but we stole a whole bunch of ideas from the SQL world. We basically said, hey, how do databases actually work? And we went and did all the same things. So Iceberg is essentially bringing SQL table behavior to the data lake world, which we thought of at the time as really upgrading our data lake into something that functioned like a data warehouse, which is, I think, why people are interested in this session today. Now, the other thing was that we had a higher goal, and that was that Iceberg should be invisible. How often when you're querying, say, Oracle or MySQL or something like that, do you really care about the files on disk or what's going on underneath your tables? Almost all of the time, you don't care because you don't need to. And that was our goal. We want Iceberg to be largely something that, oh, that's, Iceberg is doing a great job. I don't exactly know what it does, but it means that I have all these guarantees from the SQL world. So you have schema evolution. You don't have to worry about extra predicates for partitions and things like that. Also, we fixed a whole bunch of things that were just problems, like zombie data columns, mysterious performance, where if you query it this way, you get great performance. If you query it this way, you have to wait a week. That's a huge cost. And we also don't want to steal attention, right? We built Iceberg so that you don't even need to think about it. It should be fast. We should be able to automate the things that you don't care about doing. And you should be able to fix problems in place without having to migrate from one table to another and rewriting all your queries and some of those heavier weight operations that Hadoop required. Lastly, we wanted Iceberg to be a universal open standard, so that people could adopt it and so that other engines could really invest in this space and know that they're not going to, have a V2 of the standard released next week and they don't support it and they're behind. This is really a space where, in order to get investment from AWS and Starburst and all these large vendors, we knew it needed to be open. And so it was really important to us from the beginning that this is something that everyone can feel ownership of. Next slide. So Iceberg essentially delivered, and I think I talked about this a little ahead of myself, but it took the data warehouse behavior, the reason why you would go and use something like Snowflake to get that SQL behavior, to get very reliable tables, and it brought all of that into the data lake world. So you get the schema and layout evolution, hidden partitioning, declarative engineering patterns. SQL is a declarative language, but we often don't treat it that way in big data because we sort data before writing or do these tricks in order to get the engine to do what we want. We want to bring that back, and so you don't have to worry about these things. We also, worked on ways with engines like Trino to implement modern warehouse SQL. So merge, update, and delete operations, as well as time travel using things like version as of syntax. So it's sort of the best of both worlds. It is all of the flexibility of a data lake with the reliability of a data warehouse. Now, similarly to the relationship between Trino and Starburst, my company is Tabular, and what we do is we run Iceberg as a managed platform. So you may have noticed, if you've been in data infrastructure for very long, that you can't just set up Trino. You need other things along with it. You need storage. You need a catalog. You need security. You need all sorts of things. And that's not even getting into all of the needs that you have to maintain tables in the background. How are you optimizing every table? Are you having a human do it? Because that's super inefficient. How are you securing data? So we think of Tabular as a painless Iceberg based platform that very easily connects to Starburst Galaxy. So if you want a great, experience as a data warehouse in the cloud, Starburst and Tabular together are a very, very cost-effective and easy way to set that up. So if you go to the QR code here, you can sign up for a free Tabular account. And what we're going to do today is show you how to not sign up for the accounts, because that's a lot of boring forms, but we'll show you how to connect Starburst and Tabular. Starburst Galaxy and Tabular, and then we'll run through a data warehousing tutorial. Lastly, this is what our architecture looks like. So I was talking earlier about the flexibility of the data lake with the guarantees of the data warehouse. So here you see, the open data stack, and even things like Snowflake that are closed can talk to Iceberg and this tabular metadata layer and tabular access controls. But everything that you want to run can talk to S3 and Iceberg and use the same tables. You have one central source of truth and one central table store. Tabular runs the catalog, the access controls, and the services and automation to essentially take all of those things that we previously threw over to data engineers because we didn't know what to do with them. Like, oh, hey, compact those tiny files in your tables. Tabular automates those things. So it's the central table store and sort of the bottom half of your database where you can connect to any query engine like Trino or Starburst Galaxy.
Awesome. So now we're going to take you through why Trino and Iceberg equal the modern data lake. So here we have an image, right, of your typical stack of like a data lake. So you have at the bottom, you have your object storage, and then you have those open file formats that you would use on top within your object storage. And that's typically what is in the data lake sphere, right? Well, to really up level that data lake and make it something that can be usable, and everything that Ryan just said about having applying those data warehousing principles to your data lake, you need your table format. And that's where Iceberg comes in. And that's where it gives you all of that power to do that. So then the thing behind running those table formats and running on the compute and running the compute for the storage, that is the compute engine Trino. So that's what actually powers your modern data lake. And then it gives you that federation access to get to anything else that's in your orbit. So, if you have something else somewhere over there, or you need to reach something in your Oracle database really quick, you have that ability. But basically, you're having Trino power your modern data lake, which should be built with, Iceberg and your open file formats and on your object storage. And we're pretty passionate about that at Starburst. We have Iceberg as our default for Starburst Galaxy. So if there's no other way to say that, then that's how the best way to do it. So here is the modern data lake benefits, which we've already touched on, but just to really reiterate the point of you're getting those data warehouse capabilities where you're getting that fine-grained access control, those ACID transactions that are so important. And you'll see later today, getting the concurrency that you want, that high performance, but then you're applying it to the data lake. So you get to capitalize on the separation of storage and compute, the cost efficiency, the open formats, the unstructured data, and the structured data. You get all of those benefits. So using Trino and Iceberg together to apply those data warehousing principles on the data lake is what gets you those modern data lake benefits. So that was kind of the prequel. And now we're going to get into the really fun stuff where we're going to do the workshop. And before I hand it over to Ryan, just want to quickly introduce what we're going to be doing. We're going to be using, as we mentioned, Starburst Galaxy, which is Starburst SaaS offering for Trino. And we're going to be using Tabular, which is the SaaS offering for Iceberg. And what we're going to be doing is getting up and running and take you through some of those principles so that we show you the modern data lake in an application. All of the links, if you haven't already previously signed up, will be available. We'll send them out to you after the lab. They're also in the chat. If you haven't already signed up for Starburst Galaxy and for Tabular, don't worry. We'll send you the instructions. It'll be super easy. And then you can run this exactly as you want. So I'm going to stop sharing my screen and hand it over to Ryan.
Thanks, Monica. Let me grab my browser here. You guys can see that? All right.
Yep.
So here we are in Starburst Galaxy. As I mentioned, we already have created the accounts in both Starburst as well as Tabular, but they're very, very basic. So if I hop over to Tabular here in my first tab, you can see that this is just the default. So when you sign up for Tabular, you click through, you name your organization. Mine is Ryan's org. And you're presented here with a whole bunch of warehouses. So warehouses are just table spaces like a Hive warehouse, for example. You can create these going through and granting access. All of the data for a custom warehouse is stored in your bucket. But today we're just going to use the sandbox warehouse that's hosted by Tabular and that comes by default in your organization. This just gives you a little space where you can play around, get to know the product and do things like run through a tutorial like we have today. Speaking of the tutorial, there are some links in the chat. I'm going to be following the tutorial posted here, which is using Trino and Iceberg together for data warehousing. If you don't want to follow along while we're doing this live, you can just watch and then come back to this later. All the links are going to be easily available. So hopping back here, what we're going to do is go into the sandbox warehouse, and we're going to connect this sandbox warehouse over to Starburst Galaxy. So in Starburst, I went and selected this little icon here, which I think I can pop this out. Yeah, Partner Connect. So Partner Connect, you can see that there's a tile here for Tabular, and that's the easiest way to get started. You just click right on that tile, click Connect to Tabular, and we're here. We're ready to set up a tabular catalog. So a catalog in Trino and Starburst Galaxy maps one-to-one with a warehouse in Tabular. So what I'm going to do is create one called Sandbox, because I'm creating to I'm connecting to this Sandbox repository, and I'm going to say Ryan Sandbox, and you can ignore the pre-filled username and password here. For some reason, it wants to use my login credentials. But what we're going to do is fill in the warehouse name that we're connecting to, Sandbox. And now I just need an access token. To grab an access token, I just go back to my Sandbox warehouse, click on the three-dot menu, and click Create a Credential. So my credential here is going to be Starburst Galaxy, just to help me keep track of it. And then I'm going to click this to copy the credential and paste it over here in the OAuth credential section. So it's that easy to authorize Galaxy to connect as your user into all of the data that is hosted by Tabular. All right, and great, it works. We can now add this catalog to a cluster and say connect catalog. So now the catalog is created. I'm going to go ahead and give it some permissions. I don't know how we have anything set up in this demo account, so I'm just going to give everything permissions. I think it's
Nice.
probably safer that way.
That's proper engineering.
Oh, yeah. So you would actually want to have some thought put into permissions as you're doing this on your own, but I just want this to work because, it's a demo day. I already ran through this demo, by the way, and it worked perfectly, which means I probably didn't reset it properly, and we're going to have a problem. All right, I'm going to connect to my large cluster, and I'm going to do that because I like it when my queries run fast. I like the large. All right, and great, that was it. All we had to do was, paste a credential in, fill out a couple of boxes, and then, go attach to a cluster. I click query my data, and it brings me straight over here. So now in this new tab, I can run things like, okay, I'm actually in Sandbox. I can select a schema, and you can see this is pulling live from my Sandbox warehouse where I have default examples and system. Similarly, in Trino, I have default examples, information schema, which is filled in by Trino, and system. So you might be wondering exactly what those are. Well, default is an empty database that is the default one. There's nothing in there. That's where we're going to put our tables today. Inside of examples, we have some example tables. And this is actually the data that we're going to use. We're going to use this raw New York City taxi yellow data set as our source data. And then under system, we have, nothing's in there, but, right, this is a hosted repository. Under system, if you have a custom warehouse, we'll share your S3 access logs, your inventory list, and different audit tables for everything that Tabular is doing in your warehouse. You can audit those activities as well as access control activity in the system tables. So we're going to hop back over to examples and talk a little bit about what we're demoing today. So many of you may be familiar with the classic New York City taxi data set, which has had some interesting problems over the years, including, anonymization, de-anonymization, and things like that. But it's a really fun data set to work with. So what we've done here is we've created the data set just from the Parquet files that you can download. So the Parquet files are 1 per month. And so we've essentially created a Hive table here with a static month and dropped those Parquet files into those directories. So what we're going to do is load this into an iceberg table that we're about to create and basically ETL this raw data into our table as the first step. So What I'm going to do is hop over here to my query editor, and on my, oh, look at that. I have all the SQL ready to go. Let's hope it works. All right. So the first thing we want to do is create inside our default schema. We're going to create the New York City taxi yellow data set. So I'm going to run this. Wait a sec. Oh.
I think you just unselected it. So just
Oh,
go
I
on.
unselect. I didn't know I could unselect. Okay.
Surprise.
That's a nice feature. Okay, so we're going to go create the New York City taxi data set, and this is going to be our ETL table. If you want to see what it looks like afterwards, you can actually go see it in the examples warehouse. But ours is going to be in default. And so here we go, New York City taxi yellow. And you can see that all of the comments that I provided and things are here. And you can also see things on like the table activity page. Nothing has really happened yet because we just created the table. All right, back in the query editor, what we're going to do is start by inserting into that new table all of the columns and data. And we're going to clean it up a little bit, put it in the new names and all of that. And we're going to select and just do February 2019. So this is, remember, we downloaded a whole bunch of Parquet files, put them into directories, and we're just reading those Parquet files as though they were a table. So I'm going to run this insert as an initial test. And this is why I like using a large cluster, because this actually runs pretty fast. Testing this on my local laptop does not run fast.
It's always that time where you have to sit there in between the demos of like, oh, you have to do this part, but you know, always the fun stuff.
Yeah. All right. So took 18 seconds. We inserted 7 million rows-ish. Now we go back here, click the refresh button, and all right, now we can see, yep, we have about 7 million rows, a few columns. Looks like we inserted about 100 megabytes. And we can also go and see things like, snapshots. Yeah, I went from 0 records to 7 million records. And this is showing basically the history of the table as it was created. So that's cool. I can see that we did, in fact, write data incorrectly. Let's go take a look at some of what was just written. Okay, that's fun. Hopefully this is large enough for you to see. But remember, I loaded February 2019. And the sample rows I just loaded have a timestamp of December 2008. So something is obviously wrong. Let's check out what's going on here by looking at one of the metadata tables for this Parquet table. Sorry, Iceberg table. I confuse them sometimes. So we're going to look at the metadata here and see like, hey, what's going on? So we've partitioned this table that when we created it up here by a month derived from the pickup time. So this is basically saying, take the pickup time of these taxi rides and distribute the rows by the month of that pickup time so that we can keep things in nice orderly chunks of data. So I want to look at what chunks were in there. My original data set, according to the New York City Taxi Commission, should have been February 2019. What's going on? Oh, looks like we've got, now these are not human readable months. This is the iceberg representation, but it looks like we've got data from all over the place. But just a few rows. So we've got 300 rows for, let's call this 2008. The bulk of our data is in actually February 2019. So we have a lot of data here. But what's really interesting here is that the incoming data, I applied because someone said, hey, here's the month of February. The incoming data was simply wrong. Right. And because I used standard Hive partitioning, I just simply labeled it, 2019. And luckily what happened when we wrote that into the Iceberg data set is that Iceberg's automatic and sort of hidden partitioning took care of this and actually put the rows where they were supposed to go. That's really important because this is a very, very easy mistake to make, and it affects data correctness. If you were to go look at the original raw table and say, hey, how many rows were there for February 2019? You would get all of the rows we inserted, even though only 7 million something were actually from February 2019. So we can see that there are some problems with the incoming data. What do we do here? So this just raises a lot of questions. Are there duplicate rows? Probably. It doesn't seem like this was a very carefully, carefully constructed data set. So we don't want duplicates. We want to make sure that we're cleaning up the data as we put it in. So what we're going to do is use a merge statement to ensure that we insert each taxi ride only once. And if it happens to be in 2 months worth of data, we're going to deduplicate that every time we put it in. This is one of the very basic data warehousing techniques, right? It is, as your data comes in, clean it up as much as possible. Make sure you're removing duplicates. Make sure that you have some guarantees around what's going on. So here, what we're going to do is we're going to use a merge. What this does is we have some, source data that we're going to insert. Here we're saying, grab the data from my raw taxi data set. This time we're using March 2019. And then we're going to merge that into our New York City taxi yellow table. We're going to do that by matching rows and saying this is the same row if the target table's vendor ID, pickup time, pickup location, drop-off time, drop-off location are the same. Those are what we consider identical things. Now, you'll also notice that we have this weird, sort of odd window function up here. And that's because we actually need to deduplicate the rows as they're going in. So if we have duplicates in a given month, we can't say, hey, update this row twice. We need to have one and only one update. So what we're doing is we're taking the first update for a given row and saying, discard the second duplicate. So we're deduplicating here, and then we're matching that up against the table that we're writing into and deduplicating here against data that's already in the table. Then, if we don't already have a copy of that row, we insert. And so that's pretty easy. Insert these columns with all the values. This is basically the same as our insert, only we're saying, go figure out if this is already in the table. And by the way, let's remove duplicates from even getting there. Now, we've constructed this specifically to be an idempotent query so that if I run this multiple times and the rows are already in the table, then we're not going to add duplicate rows. That's a really, really important property of data pipelines that, as you modify them, as new data comes in, you're not creating duplicates if you, have bad data or your Kafka pipeline is not exactly once. It's really, really hard to get an exactly once Kafka pipeline. All right. Now we can see we have inserted 7.8 million rows. Great. That's pretty cool. Again, Iceberg put them in the correct location. We deduplicated them, and this is an idempotent query. So if I, accidentally run this a second time, what we should see is that this does not modify anything in the table. All right, and the second time we ran it, sure enough, we got 0 rows. Well, that's pretty cool. And it only took 9 seconds. All right, so let's insert a few more months worth of data. So let's go and insert April. And then when that finishes, we'll insert May. Just to give us a little bit more. Ooh, this is taking longer. Great, 7.4 million rows. Let's insert May. Didn't our original one take 9 seconds? What's going on there? Hopping over to Tabular, I'm gonna refresh this. And we should see, yep. Oh, our data definitely getting loaded. There's our 7.8 million, 7.5 million, right? We're seeing some stuff. We can also go and look at the pickup time month and see sort of the same information that we saw looking at the partitions table before. So this inserted May 2019 primarily, but oh, right, there are all those other months that we're inserting as well, including some data from the future, which is fun. I always like to time travel to the future. So this took 21 seconds. That's about twice as long as our original query. What's going on here is that as the table gets bigger, you can see this top line here of total records in our data set. What's happening is that because we are looking for duplicates, we're actually reading more and more data every time. We're saying, oh, okay, so where could all of these records be that I'm inserting? And looking for duplicates gets more and more expensive. So in order to make this a real production pipeline, I need to account for that because I don't want to read the entire table or what amounts to the entire table every single time. So to do that, I'm going to add a couple extra lines to this merge statement and basically say, I'm going to filter both my source rows and my target rows. Sorry, this is the source data that I'm merging into the table, and this is the target table that I'm merging new rows into. I'm going to filter both of those and say, all I want is this 1 month. So this is July. Pickup time is greater than or equal to July 1st and less than August 1st. I can't get my months right today. And what that does is that helps us limit both the potential matches in the source table, but also discard all those unnecessary rows from the source table, and also not read the entire target table the whole time. So what I'm going to do is run this, and what I think should happen is it'll run a lot faster than that 25 second query. Yep, already looks like it's running faster. Hopefully. Let's go. Don't make me lie. Oh, okay. So it still took 20 seconds, but trust me, it's doing a lot less work. So I don't know about the variability here, but over time, as this table gets really, really, really huge, this is going to be a really important thing that we did to make sure that we're not reading the entire pipeline. The entire table to run this pipeline. So great. We have a idempotent pipeline that's cleaning up our data. And this is actually really easy. Isn't this kind of cool that we've got, a couple tools, like we're running real data engineering workloads. And I've only been doing this for like 15 minutes now. So, start to finish, you can really get up and running quickly with this architecture. Next, let's take a look at some of the other things that you're probably going to need to do over time with your data, and see like how Iceberg and Trino together are a really good solution for everything that you need to do, not just these insertion pipelines. So I hinted earlier at some problems with the New York City taxi data set. It was de-anonymized because basically instead of having these location IDs that are several blocks in size, it originally just had locations, as in latitude and longitude coordinates. And so people were able to de-anonymize the data set by looking at the coordinates and who lives or works at a certain place, and it was kind of a problem. So they had to introduce the more granular, sorry, not more granular, the sort of masked location IDs that group several blocks together or large areas together. So say we want to do that again. We want to go and modify a whole bunch of data in this table. And instead of having a more granular trip distance, we want to round that just to the nearest mile. So you can get an idea of how long the trip was, but maybe we're not giving quite so much information about how long a given trip was to help this anonymization. So what we'll do is start by reading and just look at a few rows. We can see this trip distance measure 0.49, 1.81, 1.5, and so on. So we've got about 2 decimal places of accuracy here. And this, we want to round to the nearest mile. So I'm going to run this update statement. So update this table, round the trip distance, just replace that one column where pickup time is, less than my test data. So less than February. This is all the rows that were older in my initial data load. Seems like a good thing to test on. All right, and we modified about 42,000 rows. Let's go take a look at that data set again. Oh, there we go. Exactly what we expected. We have a distance of 3 miles, of 0 miles. We rounded everything. So this looks like what we were trying to do with the data. Now we can loop through and progressively do more updates if we choose to. But what if we're not sure that we did that correctly? What if we want to roll back? Well, we can roll back. We can do some fancy things. So Iceberg keeps track of all of the versions that you see here. So I think this was the modify. Iceberg keeps track of all these versions. We can just simply click, hey, roll back to this version in order to get there. So that's pretty cool. But what we can also do is grab one of these older snapshot IDs and time travel to the version of the table as of that time. So let's go and run this exact same query where we got the rounded trip distances and just time travel back to before that happened. And you can see, 1.82, we're getting these, unrounded trip distances again. So if you need to go recover data, you can roll back. You can see what you're rolling back to. There's a lot of flexibility. And this goes beyond typical data warehousing where you have just the latest copy of a table. The flexibility here is actually really cool. So let's roll back. Yeah, let's do that. Okay. Now coming back here, I rolled back, I verified what we're rolling back to, and great. Our trip distances are back. Very nice. All right. So that's cool. And now we can also see that these snapshots exist, but they're not ancestors of the current table state. This is the current table state. And this is included in the current table state, and this change is included, but these newer changes are actually not. All right, the last thing that you may need to do is say a certain pickup location no longer wants to be included in this public data set. So pickup location 4, which I believe was some funny name. What was pickup location 4? Alphabet City, which I'm pretty sure must be where Sesame Street is. So Alphabet City no longer wants to be included in this data set. So we're going to go and just delete everything from that data set. This is very common. You typically need to go and remove some stuff. Data changes over time, and you need to be able to do all of these things to maintain it and not just get stuck, rewriting the entire data set into a new table. Yep, 64,000 rows. And now if I'm going to write some SQL by hand in a live demo, replace this filter with the location that we just deleted. Yep, sure enough, it's gone. Now we can also do things like go over here to settings and say, I need to actually get rid of those things. So I'm going to change the minimum number of days to keep old versions around to 1 day. Or I can go and change other settings that basically even drop the table. There's a lot of stuff here that you can explore later. We have access controls, who can read, write this table, and so on. So that's basically the end of the demo, but hopefully you've learned quite a few things about what we can do with Iceberg and Trino together. And it's pretty amazing that we were able to do all of the setup to basically create a data warehouse, connect to one of the best engines in in the big data space, and run through and build an entire data pipeline in basically 20 minutes.
Yeah, they had to listen to us talk at the beginning first. And we still got all of that done.
Yeah.
So yeah, this is some of the awesome stuff. Just before we leave, I just want to shout out, we are doing Galaxy Launch Week right now. So we're talking about super awesome different features that we have throughout the week. And that includes, we talked about Starburst Gravity on the first day, cross-cloud, cross-region connectivity today. This is why we're doing this webinar. We're talking about some of the features that we can do with Iceberg and then some of the other table formats that are available. So yeah, tune in for tomorrow for our last day of launch week. And you'll see a lot of awesome information that coming down the pipe. And I just want to again thank Ryan for being here. And you can do this yourself. So I know that we were doing it here and Ryan was driving and everything like that, but you can go recreate this exact lab with all of the instructions that are available to you. We will send that all out in a follow-up email. It's also in the chat right now. All you got to do is sign up, and then you should be able to go through and do all of it. So awesome. So glad that you were able to follow it live. If there are any questions, go ahead. This is your speak now or forever hold your peace moment. I'm just kidding. You know how to reach us. But, if you have anything quick, we can answer. This would be the time. Tino, I will send you all the directions for that one. That was an easy one. Tino asked how to join the Starburst community. So I'll go ahead and get you all that info. Okay. I think we'll let everyone go early. Thank you so much, Ryan, for being here with us. And yes, please be ready to see the rest of launch week and try that demo out for yourself. Thanks.
Yeah. Thanks, everyone.